The Soviet Union and the United States sent probes with some success. 3 Mariner spacecraft made brief flybys, and the Soviet Veneras entered the atmosphere and touched down, some surviving for minutes. They managed to send back tantalizing images of an almost serene vista. NASA sent 2 more probes, Pioneer Venus 1 and 2, the latter depositing 5 small probes onto the surface. The Soviets continued their program of Venera probes with 4 successful landers and orbiters. A further 2 Russian Vega missions deposited atmospheric probes as they swung by en route to Halley's Comet.
The atmosphere of Venus is incredibly interesting because it's so different from the Earth's atmosphere. And we'd like to understand what causes these differences, because this might well help our understanding of climate change on planet Earth.
There's a very dense atmosphere, to 97% of carbon dioxide, a very strong greenhouse effect, and the temperature down on the surface is more than 450 degrees Celsius. And the surface pressure is 92 bars, so it's almost 100 times more than the Earth. So it's a very, very unpleasant place to be.
High up in the clouds, about 100 kilometers from the surface, the wind speeds are very, very high. The wind is traveling at 300 kilometers an hour, and it travels around the Earth, around Venus every 4 to 5 days. So that's one of the things we don't understand, why at the surface the winds are very gentle, and high up the winds are very, very fast. So it's a very different atmosphere to the Earth's atmosphere.
0 and liftoff of Space Shuttle Atlantis.
In 1989, the NASA probe Magellan was launched from the payload bay of Atlantis en route to Venus, its 5-year mission to radar map the entire planet's surface. The radar managed to peer through the dense atmosphere and revealed the true face of Venus. What it showed was a young surface with few craters and mostly covered with volcanic activity, lava flows and large lava plains. Surprisingly, there was little evidence of wind erosion, and the surface plate tectonics were dominated by global rift zones, unlike Earth. To date, that was the last Venus probe from NASA. It was 12 more years before Venus came under scrutiny again, this time by ESA's Venus Express. To conserve fuel for a long mission, the probe utilized aerobraking in the Venusian atmosphere to make orbit.
Very interesting discoveries of Venus was a huge vortex, a huge cloud at one of the poles of Venus that in some ways looks very similar to a hurricane on the Earth. But this is a long-standing event that's there all the time. We don't understand how it's formed, why it's there, and how it will evolve.
When we arrived at Venus 8 years ago, we detected winds at 300 kilometers per hour, very fast. But what has happened during these years, until now, they have actually increased. We now see winds of 400 kilometers per hour. And we can't really explain why that has happened.
More questions were raised by the planet's absent magnetic field.
Venus doesn't have a magnetic field. So Venus is just this big rock with this atmosphere and the ionosphere sitting in space, and the supersonic solar wind with the interplanetary magnetic field whacks into Venus, and it can't penetrate through the ionosphere. So the interplanetary field lines just sort of pile up ahead of Venus, like cars on a freeway. This solar wind whacking into it essentially sort of strips off the atmosphere, and it literally forms this long tail, like a comet that's stretching out into space. Pioneer Venus Orbiter was the first spacecraft to really thoroughly explore that night side region where the atmosphere is all escaping away. And it discovered this really mysterious phenomena which has yet to be explained. Imagine that we're flying from pole to pole on the night side, so we're feeling the plasma around us, and then suddenly the ionosphere disappears. And then it sort of comes back. And this is what an ionospheric hole is. It's like a chasm in the sky, a big hole where the ionosphere is just absent. So Pioneer Venus Orbiter basically measured inside these things, and we saw that there is very little plasma, and there's all this magnetic field. And from that, they sort of suggested that this is essentially a magnetic structure that's sitting in the night side. I wanted to see if I could go looking for these things with Venus Express. What we saw is essentially this really exciting, strong, straight magnetic field lines that we expected, and really boring plasma signatures. It shows us that this is a magnetic structure, right? This is a tube of interplanetary magnetic field that, well, PVO saw it coming out of the ground, and now we've seen it way out in the tail. So these things really continue out to much higher altitudes than we previously have found them.
As Venus Express neared the end of its mission, scientists made some risky aerobraking maneuvers to bring the probe much lower in orbit to make close-up observations of the planet. These maneuvers involved daring plunges into the hostile atmosphere only 130 kilometers above the planet's surface.
For the aerobraking, we wanted the most area possible to get the most friction possible, but that also generates heat. And so what we did was we went into the atmosphere in this direction, because this face of the spacecraft, which had been attached to the rocket originally when it was launched, was most able to take the forces and the temperatures. We also turned the solar panels so that the side with the actual solar arrays was in the back to maximize the area as we went through the atmosphere, to maximize the amount of friction and to get the most amount of braking. What we saw that was a little unusual is the variability in the pressure, as if there were waves within the atmosphere. And so that possible wave-like structure was not expected. And analyzing that data will keep scientists busy for a little while yet.
Venus Express carried a suite of 7 instruments: magnetometer, spectrometer, and several cameras to study the atmospheric winds and surrounding space environment. Venus Express outlived its planned 2-year mission by another 7, and only recently was it directed to ditch into the planet's atmosphere. The Japanese have made the most recent attempt to reach Venus with Akatsuki, whose planned observations are to include cloud and surface imaging with infrared cameras. Their main focus is the Venusian meteorology, including confirming the presence of lightning and any current volcanic activity. The probe failed to enter orbit on its first attempt, and JAXA are hopeful when the probe's heliocentric orbit returns it to Venus that a second attempt will succeed very soon. There are many plans afoot to return to Venus. Even a manned mission has been studied by various groups. One such study conducted for NASA produced HAVOC, a high-altitude Venus operational concept. It would rely upon 2 spacecraft sent into Venus orbit, the first unmanned atmospheric descent stage and the second orbital return craft carrying the crew. They would dock, transfer crew to the descent stage, and proceed to deorbit. Once into the upper atmosphere, a parachute would deploy, slowing the descent and allowing the deployment of a dirigible craft to inflate and carry the crew at high altitude.
Looking good, Havoc.
there they would study the planet below. The return journey for the crew would begin with a high-altitude launch back into orbit, where they would dock with the orbiter, transfer crew and equipment, and then make the journey back to Earth. There they could dock with an Orion capsule for the return to